What's up, everybody? And so, the new Mars project is the new frontier, correct? Well, check this out. What would happen if we were to breathe on Mars? This is awesome. Check it out.
Imagine you are now on the Martian surface, and you attempt to breathe there without the life-sustaining oxygen supply of a spacesuit. The outcome would be an immediate fatality. You would die. Due to the exceedingly low atmospheric pressure, your blood would also start to boil simultaneously. We are embarking on a fascinating journey to unravel one of the biggest mysteries. Could people actually breathe the air on Mars? Strap in, because this is going to be an interplanetary adventure that you will not want to miss. Mars, often referred to as the Red Planet, has an atmosphere like Earth, but both differ significantly from the familiar experiences we encounter on Earth. It's thin, really thin, about 100 times thinner than what we breathe here. Earth's atmosphere comprises 78% nitrogen, 21% oxygen, 1.0% argon, and 0.04% carbon dioxide. There are also trace amounts of various other gases. But the Martian atmosphere is mainly composed of 95% carbon dioxide, 3% nitrogen, and 1.6% argon. It also contains traces of oxygen, carbon monoxide, water, methane, and other gases, in addition to a substantial quantity of dust. Meanwhile, dust is another problem on the Martian surface. The presence of suspended dust in the atmosphere makes the Martian skies tan. This does not sound promising for breathable air, but we cannot jump to conclusions just yet. Keep watching to find out why. Now, let's get to the heart of the matter. Oxygen. We, humans, need a good dose of oxygen to keep us going. On Earth, oxygen makes up around 21% of the atmosphere, but on Mars, it is a mere 0.13%. That's, well, quite a difference. So you might be wondering, could we pack a few oxygen tanks and call it a day? Not so fast. The challenge lies not only in the low levels of oxygen, but also in the thin atmosphere. The atmosphere makes it tricky for our bodies to actually absorb that oxygen. But where there is a will, there is a way. Scientists and engineers have been cooking up some seriously cool ideas to make Mars more hospitable. From massive biodomes that mimic Earth's atmosphere to ingenious devices that extract oxygen from Mars's soil. There is no shortage of creative thinking. While these solutions sound incredible, they are still in the works. So, could people breathe the air on Mars in the future? Let's dive deep into some possible ways. One approach is to extract oxygen from the carbon dioxide in the Martian atmosphere. This could be possible through a process called in situ resource utilization, or shortly ISRU. Mars has a thin atmosphere composed primarily of carbon dioxide. But hidden within this Martian air is the key to creating life-sustaining oxygen. Here is how it works. The process called ISRU is forefront. In this case, focusing on Mars's atmosphere is needed. Step 1 involves collecting Martian air, primarily composed of carbon dioxide. Special equipment on the Martian surface does this job. Step 2 takes place inside a reactor. The collected Martian carbon dioxide undergoes a chemical transformation. During this process, oxygen molecules are separated from carbon dioxide molecules. The extracted oxygen is then released and stored for use by astronauts in the Mars habitat. The result: astronauts on Mars can breathe oxygen, just like on Earth. This breakthrough technology not only provides a breathable atmosphere, but also reduces the need to transport vast amounts of oxygen from Earth. This makes Mars colonization more sustainable. There could also be potential use of water ice on Mars as a source of oxygen. In this regard, one remarkable method involves a process called electrolysis. We know that 2 hydrogen and 1 oxygen exist on Mars in the form of water ice. Mars rovers equipped with drills are essential for this task, extracting water ice from beneath the Martian surface. Now, the magic begins with electrolysis. This process takes place inside a device called an electrolyzer. Inside the electrolyzer, water is introduced and an electric current is applied. The electrical current causes water molecules to split into their component elements, hydrogen and oxygen. The oxygen produced during this process is then collected, purified, and stored for astronauts to breathe. This stored oxygen can be released into the habitat, creating a breathable atmosphere for astronauts. Another innovative solution involves harnessing the power of biology to produce life-sustaining oxygen. Specifically, plants or algae are crucial in this case. Photosynthesis is the key. It is the way plants use sunlight to convert carbon dioxide into oxygen and glucose. First, introducing these oxygen-producing life forms to Mars is needed. Mars rovers play a crucial role in delivering plant seeds or algae to specially designed greenhouses. Inside these Martian greenhouses, astronauts provide the necessary care, ensuring the plants receive adequate light, nutrients, and water. As the plants or algae grow, they perform photosynthesis, releasing oxygen into the greenhouse atmosphere. An air circulation system then collects and purifies this oxygen. It's subsequently released into the Mars habitat, creating a breathable atmosphere for astronauts. All right, let's talk about spacesuits. If you're dreaming of strolling on the Martian surface, a trusty spacesuit is your best friend. An astronaut present on Mars would not have the capability to breathe the native Martian atmosphere. They would demand a spacesuit equipped with oxygen in order to conduct outdoor activities. High-tech suits are designed to protect astronauts from Mars's harsh conditions, including its thin atmosphere and extreme temperatures. They provide a cozy little environment with oxygen to breathe and everything. So, while you cannot exactly take a deep breath of Martian air, you could definitely explore the wonders of the red planet with the right gear. From innovative technologies to the magic of well-designed spacesuits, humans are pushing the boundaries of exploration. So can we breathe the air on Mars? Not quite. But who knows what the future holds? As we look to the stars, extracting oxygen from Martian resources is a crucial step toward turning Mars into a new home for humanity. If you have enjoyed this cosmic adventure, don't forget to hit that subscribe button and turn on those notifications.
Are you having trouble paying for healthcare, rent, gas, groceries, and other bills? You've got to see this. The government is basically giving...
We're determined to discover traces of life on remote exoplanets. So we cast our gaze far beyond the boundaries of the solar system and into the great abyss of space. But actually, just several hundred years ago, a unique world was detected comparatively close to us. There are clouds in its atmosphere. It rains there, and on its surface, great rivers flow into lakes and seas. Still, the conditions on this fascinating celestial body are lethal, with the surface bound by incredible cold. So what is really happening on Titan? First to space. Titan is located about 10 astronomical units from the Sun and is outside the habitable zone of our star. It is Saturn's largest satellite, and its orbit lies well outside the Great Rings, at a distance of about 1,200,000 kilometers from the center of the planet. The trajectory of the celestial body is close to circular, and a complete orbit around the gas giant takes a little less than 16 Earth days. Titan's diameter is 5,152 kilometers, which is 5.6% larger than that of Mercury. At the same time, the mass of the celestial body is relatively small at only 1.35 times 10 to the power of 23 kilograms, which is about 40% of Mercury's. Calculations show that the satellite's average density is about 3 times less than that of the Earth, which means it has a completely different chemical composition. According to contemporary concepts, Titan has a massive core at its center, about 3,400 kilometers in diameter and made up of various silicon compounds. It is surrounded by a thick layer of densely packed ice, which is at the bottom of a cold liquid ocean hundreds of kilometers deep. The ocean, in its turn, contains large amounts of dissolved ammonia, methane and various caustic salts, so that its freezing point is markedly lower than that of ordinary water. For this reason, Titan's subsurface ocean remains liquid even in sub-zero temperatures. It is bound by a thick crust around 100 kilometers thick, consisting of a mixture of water ice and methane hydrate. The tidal forces of the nearby Saturn are continuously deforming it, causing massive rifts and fractures. This causes large cryovolcanoes to form, ejecting great quantities of methane, ammonia and water onto the surface of the celestial body. Methane plays about the same role in Titan's atmosphere as water vapor on Earth. The fact is that the average surface temperature of the satellite is only about 94 Kelvin, or 179 degrees Celsius below zero, which is slightly below its boiling point. Natural variations in this parameter cause hydrocarbon vapors to condense and precipitate, forming methane seas, lakes and rivers. Titan's atmosphere is composed mainly of hydrogen, which makes up about 98.4% of its volume, while methane accounts for about 1.6%. Due to its extremely low temperature, the satellite's atmosphere remains condensed near its surface, and the ring of the mountains surrounding it is less than 500 meters high. Most of the surface of the celestial body is permanently obscured from our eyes by multi-layered clouds and an orange-yellow tholin haze. This unique weather phenomenon is a fog formed by tiny droplets of liquid methane and dissolved organic matter, which gives Titan its characteristic hue. This haze pervades Titan's surface, absorbing and scattering visible light but transmitting infrared light. This peculiarity leads to an unusual anti-greenhouse effect, which cools the satellite's surface by roughly another 10 degrees. This effect makes Titan difficult to explore, but thanks to the Cassini's orbiter's infrared cameras, Titan was in parts mapped out earlier this century. Of course, it is not as accurate as we would prefer, but even this much is enough to outline the most striking features of the celestial body's surface. The face of Saturn's largest moon is full of contrasting spots. Some of these reflect most of the light that falls on them, while others, the face of Saturn's largest moon is full of contrasting spots. Some of these reflect most of the light that falls on them, while others are relatively dark in color. One such area is slightly south of the equator and is called Aztlan. One of Titan's highest mountains, Mount Doom or Doom Mons, is located here, towering about 1.5 kilometers above the surrounding plains. The whole mountain reaches up to 60 kilometers in diameter. Its summits are craters, and its slopes have relatively fresh traces of turbulent flows. This may suggest that Doom Mons is an active cryovolcano. To the northeast from it is Titan's deepest depression, called Sotrapatra. It is a giant depression about 30 kilometers long, the bottom of which is located about 2 kilometers below the adjacent plains. It is thought to be the mouth. The world is on fire.
was there, in San Francisco. When the whole city was coming down, these guys were taking pictures, like they'd been waiting for it.
You think that your father was working for them?
This stuff was in a safe.
Who are they? What's Monarch?
This is the world we live in. Monsters are an inescapable reality.
Those files belong to us, and they are more important than you could possibly imagine.
This is going to give me nightmares. Now, you can choke down that Monarch lie. About your father disappearing. Or we can find out what really happened before it's too late. This world is not ours. Believe me.
It's so much more vast than we could possibly imagine.
These monsters and Monarch have taken everything from me. No more.
The world is on fire. If you want to save millions of lives, we can use some help.
Attention, the $6,400 health subsidy is ending and many Americans forgot to sign up. Working Americans earning less than $60,000 per year are eligible to receive the $6,400 health subsidy for 2023. Unfortunately, the subsidy has a deadline for tomorrow. Your last chance to sign up is about to end. If you haven't been able to keep up with rent bills or groceries, pay attention because this is the largest government financial health assistance program to come out in decades. The program is giving up to the $6,400 in government-approved health relief to lower-income workers. But sadly, this program will not last, and this is the last chance to sign up. Millions of Americans are calling the hotline and claiming their health credit. People are using the savings for essentials like rent, groceries, bills, and utilities. Sadly, this is your last chance to qualify is running out because funding for it is coming to an end. If you are seeing this, you have a chance to claim this benefit. Act now, and to find out if you qualify, just click on the link in this video. Remember, it's completely free to sign up and millions of Americans qualify, but only if they act on it before tomorrow's deadline. Get the thousands you're entitled to by tapping below and calling our hotline. Act now.
The huge cryovolcano, and is part of a single tectonic structure along with Deux Monts located close by. To the north of Deux Monts, there stretches the immense Mahini Fluctus, a vast area covered by Deux Monts' ejections. The area extends for about 180 kilometers and varies in width from 15 kilometers in the south to 60 kilometers in the north, where torrents of frozen material alternate with expansive fields of sand dunes consisting of a mixture of frozen methane and water ice. Our flight will continue over the dark area of Fensel. The largest impact crater of the celestial body, Minerva, is located in its northwestern part. It reaches 440 kilometers in diameter, which is about 3 times larger than any other crater on Titan. The depression is about 200 meters deep, and the ring of the mountains surrounding it is less than 500 meters high. The fact is that according to studies, Minerva is not only the largest, but also the oldest extant crater on Titan. Different estimates put the age of the crater at between 300 million and 1.2 billion years. Erosion and tectonic processes have severely damaged the crater, and it is only thanks to its sheer size that it is still visible. Minerva has a well-defined internal structure. At its center there is a small flat plain, surrounded by a ring of hills. This region, with a total diameter of about 200 kilometers, is rather light and clearly visible from space. It is surrounded by a so-called moat, a stretch of dark plains about 50 kilometers wide. This is followed by a ring of low mountains that form the outer boundary of the crater. Our flight next takes us to the south. Here is one of Titan's most impressive and mysterious landmarks, Hautei Arcus. This is a unique formation in the solar system. It is a bright, arc-shaped region about 600 kilometers long. Radar data from Cassini shows that Hautei Arcus is a natural boundary between the Rocky Mountains in the northeast and a wide valley in the northwest. It is also noteworthy that some parts of this area change color from time to time. This phenomenon is thought to be linked to the eruptions of cryovolcanoes, whose emissions cover the surface of the satellite in a thin layer and then flow into a nearby valley or evaporate into the atmosphere. From space, one can clearly see light channels similar to riverbeds running from the mountains of the Hautei Regio to the northwest. This is where Xanadu is located, which is a vast lowland area with highly rugged terrain. Its northwest boundary is formed by Mithrim Montes, which are three parallel ridges stretching for about 150 kilometers, with an average height of 1.9 kilometers. Among the peaks of the southern range is the highest peak on Titan, reaching 3,337 meters. Standing on top of it and looking west, you can see a vast dark plain stretching several hundred kilometers in front of you. It is called Shangri-La, and it is thought that this whole area used to be flooded with liquid methane. It is assumed that it may have persisted beneath the topsoil, similar to the Earth's underground water. Most of this region is below average elevation and has a comparatively flat terrain, but lighter hills can be seen in some places. In the past, these may have been islands in the middle of a hydrocarbon sea. To the west of Shangri-La is the bright Adiri upland area, clearly visible against dark regions around it. The area extends for up to 2,500 kilometers and is a veritable network of numerous drainage canals and caves clearly visible in the photographs. These are thought to have been formed by abundant flows of liquid hydrocarbons. To the west of Adiri is the vast dark lowland area of Belet, and to the east, near the border with Shangri-La, is the Huygens landing site. So far the only vehicle that got to touch down on the surface of an object in the outer solar system. The descent probe was part of a science program called Cassini-Huygens. Together with the Cassini automatic probe, it left Earth in 1997 to spend 7 years in interplanetary space. The spacecraft entered the orbit of Saturn only in 2004, and in early 2005, Huygens reached Titan and plunged into its atmosphere towards new discoveries. Cassini, on the other hand, remained in orbit around the gas giant to carry out its part of the research program, as well as to continue serving as a transponder for the lander. The probe spent just under 2.5 hours in the atmosphere, gradually dropping speed using a sophisticated parachute system. Eventually, by the time it touched down on the surface, its speed was 4.4 meters per second. The probe successfully withstood a momentary 15-fold overload and soon went on to collect information. Huygens was equipped with a vast array of scientific instruments, most of which were designed to study different aspects of the satellite's atmosphere. The probe used them to measure the strength and direction of air currents, as well as the electrical conductivity, temperature, and composition of the atmosphere. The probe also took photographs and made audio recordings, and on landing, it examined the composition and properties of the ground. The first thing the cameras saw after making contact with the surface was a flat plain, dotted with rounded rocks of various sizes, the shape of which clearly indicated the impact of powerful fluid currents. A special drill was also used to sample the surface, penetrating 15 centimeters into the ground, while multiple sensors measured its density, texture, and composition. It turned out that a thin layer of small rounded pebbles lay on a relatively soft but dense substrate, similar in consistency to wet sand or dense snow. Also, methane gas was released during the drilling process. The ground at the Huygens landing site is believed to have been like sea sand, saturated with liquid hydrocarbons. In total, the probe transmitted around 500 megabytes of information to Earth, including 350 photographs. Further careful analysis revealed several unique features of the celestial body related to its atmosphere. For example, it turned out that at an altitude of about 80 kilometers, there is a layer of almost complete calm, as if separating Titan's atmosphere into two parts. Neither air currents of the upper atmosphere nor winds of the surface reached this layer. What caused this phenomenon is not yet known. Another feature is that Titan has two ionospheres. The first of these is located at an altitude of about 1,200 kilometers. It is a layer of heightened electrical conductivity with a large concentration of ionized particles. This layer is known to be formed by stellar wind streams and cosmic radiation. The second ionosphere lies much lower, at an altitude of about 60 kilometers, and the reason for its formation is still debatable. Moving northwest from the Adiri area, we reach Titan's largest hydrocarbon reservoir, the Kraken Mare. Its total area reaches 400,000 square kilometers, which is slightly smaller than the Black Sea. Due to the high viscosity of the liquid hydrocarbon mixture, it has not yet been possible to measure the exact depth of the reservoir. It is only known that in most of the area, it is over 200 meters. Another large natural basin, the Ligeia Mare, is located slightly to the north, near Titan's pole. Its diameter reaches 500 kilometers, and its area is about 100,000 square kilometers, which is about 3 times larger than Lake Baikal. The seas are connected to each other by the narrow and long Trevis Fretum, 173 kilometers long. Also in the subpolar region, there are many smaller lakes and lagoons filled with liquid methane. In 2014, analysis of earlier images beamed back by Cassini revealed a large bright object on the surface of the Ligeia Mare. On comparing photographs taken at different times, it was established that within a few months, the mysterious object had grown to 260 kilometers in diameter to disappear almost instantly without a trace. Several
You know why I love Halloween?
Why?
People give me Kit Kats for free.
Son, you're 8. All your Kit Kats are free.
Happy Halloween! Have a break, have a Kit Kat.
hypotheses have been put forward to explain it. According to one of them, temperature differences lead to a constant stirring of layers of liquid hydrocarbon mixture in the Ligeia Mare. This causes nitrogen bubbles to form and rise to the surface from the depths of the reservoir, and thus form large clusters of persistent shiny foam. Due to the high viscosity of the hydrocarbons, such bubbles can reach 4.5 centimeters in diameter and remain stable for months. From space, these structures resemble large islands because they reflect infrared radiation well. Such bubbles would have been a significant hindrance to the operation of a submersible probe, which was scheduled to be launched to Titan back in 2010. However, the mission was postponed indefinitely for various reasons. A higher priority was given to the Dragonfly program, which NASA is working on now. The vehicle is currently in the design phase and has just recently passed key tests of its blades. The launch from Earth is scheduled for 2027. As conceived by its creators, Dragonfly will be an octocopter, an aircraft with 4 twin propellers. This design will allow it to stay in the air even if it loses several blades, unlike its predecessor, the Ingenuity Mars helicopter. A radioisotope thermogenerator, powerful enough to enable the vehicle to climb to a height of 4 kilometers and travel at a speed of about 36 kilometers per hour, will be used as the power source. The scientific capabilities of the probe are also impressive. It will be equipped with a versatile camera capable of producing both panoramic photographs of the surrounding terrain and macro images of the ground. At the same time, the mass spectrometer will make it possible to determine the chemical composition of atmospheric samples and the internal structure of rocks. Perhaps Dragonfly's data will help us clarify an important question. Do we at least have a chance of encountering primitive life? The possibility of life on Titan remains hotly debated. On the one hand, the extremely low surface temperature, the presence of extremely toxic hydrocyanic acid in the atmosphere, and the absence of liquid water would likely rule out the presence of biological life as we know it. Titan's atmosphere, on the other hand, exhibits an incredible diversity of organic compounds. Nitrogenous bases and amino acids, which are the building blocks of proteins, RNA and DNA, could be naturally synthesized on its surface. It is also known that liquid methane can serve as a solvent and potentially play the role of water in biochemical reactions. In addition, experiments show that under certain conditions, a mixture of liquid hydrocarbons with phosphine forms an environment similar to the primordial soup of the early Earth. This means there's a chance of encountering downright exotic forms of life on the surface of the satellite. Titan is a unique world, fascinating and mysterious. Winds and rainfalls are common on its surface, which is crossed by rivers so similar to those on the Earth, but so different at the same time. For all we know, there is much more to the universe than we can imagine, and it's not everywhere that life looks the way we know it. Could this phenomenon that we've been painstakingly trying to detect on trillions of planets around us actually be pretty much in our backyard? The universe is so amazing and diverse. Countless stars are scattered across its expanses, and each and every one of them is uniquely mysterious and remarkable. Every day, dozens of new stars are detected, and the exoplanets orbiting them are just as unique. Still, while striving to discover other worlds, we should not neglect our own system. The only place in the universe with conditions favorable for the genesis and evolution of life as we know it. There are 8 planets in the solar system, as well as dozens of satellites and millions of minor celestial bodies which remain understudied even in spite of the long years of observations and research. And today, we invite you to take a little tour and see some of the most exciting ones. We will start out at the very heart of our system, in the devastating heat of its star, the Sun. Flying by Mercury, which is scorched by its relentless rays, we will pass by Venus, shrouded in layers of clouds. After that, we will take a break on our native planet, the Earth. A journey to the past will give us insights into how the looks of its earlier inhabitants changed, from prehistoric saurians to the much more dangerous and unforgiving creatures, humans. After that, we'll proceed to the mysterious and barren Mars, which will be followed by a visit to a tremendous area of cosmic chaos where the trajectories of millions of celestial objects intermingle. By following an elaborate route among them, we'll reach Jupiter and Saturn, as well as their mysterious satellites. At the end of our journey, we will get as far as the dark edge of our system, where sun rays and heat don't reach. Here we'll make acquaintance with the gloomy world of Pluto and its enigmatic satellite Charon. After looking at their barren plains, we'll move further on, beyond our system's boundaries, and try to catch up with the Voyagers, the space roamers that have been doggedly cruising towards the stars for the past half a century. Let's get ready, and we begin. Cosmo. The first outer space. On the 21st of November 2021, the Parker Solar Probe was just 8.5 million kilometers away from the Sun. It was its closest approach ever to our star. This means that it was also the first probe that got to brush against the Sun's corona, the extremely hot outer layer of our parent star. But why was it necessary to go through a number of technical difficulties and approach the Sun that close? What is Parker after that it had to get that near the star, to areas where everything around turns into ash? To realize the purpose, we have to see what we already know about our system's star. To begin with, the Sun is a main sequence star whose age is approximately 4.6 billion years. It currently falls into spectral class G2V, which on balance makes it a typical yellow dwarf. The Sun's surface temperature is about 5,800 Kelvin, which is 5,530 degrees Celsius, but it should be mentioned that there are both colder and hotter areas to be found on it. Incidentally, the star's inner layers and its outer corona are as scorching hot as millions of degrees. But for all that, they barely contribute to the visible radiation. The Sun's average diameter equals around 1.4 million kilometers, which is 109 times that of our Earth. As for the star's mass, it reaches 2 times 10 to the power of 30 kilograms, or 333,000 times that of the Earth, and actually accounts for 99.9% of the mass of the entire solar system. We're used to seeing the Sun as small, but in fact it is larger and brighter than 80% of all the stars in our galaxy that we know of. Hydrogen accounts for 92% of the Sun's overall volume. In one of our previous videos on stellar evolution, we mentioned that it is mainly this gas that fuels thermonuclear reactions for the overwhelming majority of stars when its temperature reaches incredibly high values. As they merge, hydrogen nuclei release great amounts of energy and transform into helium, which gradually accumulates in the star's center. At the moment, helium accounts for 7% of the Sun's volume and 25% of its overall mass. In addition to helium, stellar matter contains other elements as well, like carbon, oxygen, nitrogen, and iron, but their percentage is quite negligible. The Sun has an elaborate structure and is made up of several layers which differ in their properties. A massive core is at the center of the star. Estimates show its diameter to measure 25% of the Sun's overall size. The core's temperature measures as much as 14 million Kelvin, while 1 cubic meter of the material weighs around 150 tons. It is here that thermonuclear reactions, the source of energy for our star's luminosity, run their course. Every second, approximately 4.26 million tons of stellar matter is transformed into luminosity as a result of these processes. The core is surrounded by the so-called radiation zone, which continues to the point of 0.7 the Sun's radius. The density of matter in this area is too great for it to get mixed up thoroughly, and thus to carry heat to the upper layers of the star. That is why the way energy is transferred here is this. Particles of stellar plasma are continuously absorbing photons and radiating them again. Mathematical modeling shows that the temperature in this part of the star dramatically changes from 7 million Kelvin in its depth to 2 million Kelvin on the outer boundary. Estimates reveal that a quantum of light produced by the core may stay in the radiation zone from 10,000 to 170,000 years, and only then to move on to the next layer of the Sun. The one lying above, known as the convection zone, forms the Sun's outermost layer and is comparatively dense. Stellar matter here is more rarefied and changeable, which gives rise to enormous vortices in the convection zone. These vortices carry hot plasma from deeper regions of the layer to the star's surface, as it were, while plasma masses from the outermost areas, slightly cooled, move down. These convection cells remain stable for 10 to 15 minutes, after which they get destroyed to give rise to new vortices again. This continuous movement of matter creates a magnetic field, which pervades the entire inner part of the solar system. The Sun is also surrounded by an atmosphere. It is made up of several layers of elaborate structure. The lowest one is called photosphere. This area emits most of the star's visible light, so when watching the Sun, it is actually this photosphere that we see. As for its thickness, it measures from 100 to 400 kilometers, with a temperature fluctuating between 6600 and 4400 Kelvin, or between 6330 and 4130 degrees Celsius.
Oh, that's not that hot.
Higher up lies a more rarefied area around 2000 kilometers thick, known as the chromosphere. It can be observed from the Earth at the time of a total solar eclipse, or else by employing special equipment. This area is extremely hot, with the temperature fluctuating between 4000 Kelvin and 20,000 Kelvin. Interestingly, its outer border is covered with spicules, continuously active jets of hot gas spurting up a staggering 5,000 to 10,000 kilometers high. The uppermost area of the Sun's atmosphere is called the corona. It consists of giant prominences, flares, and emissions that may reach 1 million kilometers in size. The matter making up the corona is remarkably rarefied and incredibly hot, with an average temperature of 1 to 2 million Kelvin and the peak at 20 million Kelvin. It is this area that is occasionally crossed by the Parker probe, and every time the spacecraft immerses deeper and deeper into the blazing abyss. Calculations of the energy flow released by the photosphere will show it to be insufficient to heat the chromosphere and corona to such mind-boggling temperatures. This means that there are some physical phenomena concealed in the Sun that we have not yet discovered, which additionally heat up the upper layers. There are several scientific hypotheses that attempt to account for this thermal paradox. According to one of them, the chromosphere and the corona gain additional energy by dispersing magnetic shock waves. Another assumption explains it as an effect of charged particles' acceleration in the star's exceptionally powerful magnetic field. The Parker Solar Probe was specially designed in order to get to the bottom of these phenomena and to study obscure processes in the upper layers of the Sun's atmosphere. This probe is part of NASA's project known as Parker Solar Probe, launched back in 2009. 9 years later, on the 12th of August 2018, Parker took off from the surface of our planet on its one-way journey to the Sun to fulfill its mission. However, before getting that far, it had to execute a number of maneuvers to enter the desired orbit. By using Venus's gravity, Parker slowly adjusted its trajectory, drawing ever so closer to the scorching blazing ball in the center of our system. It was ready to withstand the star's searing heat. The probe had been designed with a heat shield, and all the equipment had been made with a view to extreme conditions to be faced. Besides, Parker's calculated orbit is supposed to lie in the Sun's immediate proximity for a comparatively short time, after which it pulls back and has a chance of giving out heat to space. This alleviates effects of thermal exposure. The probe's main task is to define the structure and dynamics of the magnetic fields in the Sun's immediate proximity. Also, Parker is supposed to gauge the energy flow emitted by the star to capture particles of stellar wind and to register wave-like processes in the Sun's corona. As a side mission, the probe took photos of Venus and the comet ToNoAvaiL as it was drifting towards our parent star. To deal with the missions successfully, the probe is equipped with a wide range of scientific instruments, like photo cameras, instruments for capturing particles, magnetometers, as well as radiation and radio wave detectors. A number of factors toward this mission. In addition to critical temperatures, the measuring instruments are exposed to an extremely powerful flow of ionizing radiation. The Sun creates strong interference in the microwave range around itself, which means that transmitting the data collected by the probe to the Earth is no easy matter either. Still, the Parker probe is carrying on with its mission. With every completed spiral of its orbit, the distance to the star shortens. In late February 2022, it is to pass through the Sun's corona yet again, in order to collect a new portion of data. By 2024, the distance between the probe and the surface of our star will shrink to become an all-time short, just 6.5 million kilometers. Estimates show that when the probe is in its perihelium, its solar shield may heat up to 1,370 degrees Celsius, which is 3 times hotter than Mercury's sunny side and only slightly lower than the melting point of iron. Even now, the probe is whizzing at a speed of 163 kilometers per second in its perihelium, but it will eventually accelerate to 200 kilometers per second, which will make it the swiftest man-made space object made so far. The probe's life expectancy cannot be that long. On reaching the closest possible point to the Sun, Parker will manage to complete several orbits around it, which is supposed to take roughly a year. All this time, it will keep losing speed, and the scientific instruments on board will be exposed to extreme temperatures and powerful radiation. Eventually, they will all be out of order, and the probe itself will descend into the scorching depths of the Sun to be totally swallowed up by a fathomless ocean of blazing plasma. But before it happens, Parker will beam great amounts of useful data back to the Earth, which will help us make yet another step in space exploration. This is a potent proof that Parker's flight will not have been wasted. Mercury lies relatively close to the Earth, but its exploration has always been associated with a lot of difficulties. On account of its close proximity to the Sun, it can be observed in the sky only at the very horizon, and
Mr. Switch. When you come to winning, we better. The team loyal to me. Do it how we stand together. If you fall, better pick him up. Go down, better get back up.
Do a switch. Trying to make a name for yourself, yeah?
Where are we going to next? I say Bella. You don't get a vote. I need something that stands out, but also blends in.
Tired of my smoke on the go. Never take me from the door. Think they with a coat. Follow where I'm going. Ain't gonna be giving them rope. Slaughter gang, you can get pulled. We the ones up in the scope.
It's game time, Switch. What do you think?
I think it screams, I'm over here.
Stay frosty, Switch.
Yo, Rook, where's your squad at?
We have to stick to the plan.
Check the time.
Hey!
You! Come with me. Today's your lucky day, chiquito.
You ready? I'm ready. Alright, let's get this. The squad's out. When you come to win, we better. The team loyal to me. Do it how we stand together. big Glock and I got my tub, but they know they ain't f***ing with us.
When you're already a great nurse, but you're called to do more, you belong at Chamberlain University, where our community empowers you with the skills you need to become the nursing leader you were meant to be. Chamberlain University, belong to something greater.
This either shortly before sunrise or immediately after sunset. This is actually why ancient astronomers took Mercury for two different celestial bodies, which were given different names. Only the advancement of observation equipment enabled scientists to gradually reveal some of this unusual world's mysteries. The accumulated data shows Mercury to be the smallest planet in the solar system. Incidentally, it is even beaten by some satellites. Its radius measures 2,440 kilometers, which is roughly 38% that of the Earth. The celestial object is remarkable for its almost ideally round shape, as the difference between its equatorial and polar diameters is not over 1 kilometer. At the same time, given its modest size, Mercury has a surprisingly big mass. It equals 3.33 times 10 to the power of 23 kilograms, which is approximately 5.5% that of the Earth. Comparing Mercury's parameters with those of celestial objects close to it in terms of their size, Mercury is heavier than Ganymede and Titan put together. And that in spite of the fact that both of those objects' diameters are bigger. It is probably due to the fact that there's a massive metallic core with a radius reaching as much as 2,000 kilometers, accounting for about 57% of the planet's volume. The core is enveloped in a 400-kilometer layer of mantle made up of molten silicate rocks. The mantle, in its turn, is covered with a hard crust as thick as 15 to 37 kilometers. As for the planet's surface, it is vastly pockmarked with craters. Their analysis shows the celestial body not to have been noticeably geologically active for the past 3.8 billion years. Bright sunlight presents difficulties in observing Mercury through a telescope. However, this had been the only way of studying the planet until as recently as the second half of the 20th century. Everything changed in 1974, when the space probe Mariner 10 reached the planet's environs. It took pictures of 45% of the celestial body's surface, and also gauged its temperature and magnetic field. In addition to that, the probe's sensors registered the exceptionally rarefied atmosphere, made up of helium and other gases. 30 years later, on the 3rd of August 2004, another spacecraft took off the face of the Earth. Messenger. It took a long 11 years to reach its target, but the little probe did tackle all obstacles and eventually accomplished its mission. In the period from 2011 to 2015, Messenger beamed back hundreds of thousands of images for scientists to study, including pictures of Mercury's almost entire surface. Thanks to these pictures, important data was obtained on the celestial body's inner makeup, and various features of the planet's relief were detected, including unique ones in the solar system. Also, Messenger's sensors helped supply us with some knowledge about solar wind and its unusual interaction with the planet's magnetosphere. Mercury follows an elongated elliptical orbit around the Sun, which takes 88 days to complete. In its perihelium, the planet approaches the Sun as close as 0.31 astronomical units, with the distance in the aphelium 1.5 times as big, at 0.47 astronomical units. Mercury's orbital resonance, unique in the solar system, is of special interest. Its stellar day equals 58.65 Earth days, which is 2/3 of the Mercurian year. This makes the planet to face the Sun alternately, first with one side, then the other in the perihelium. These regions are exposed to solar radiation most, and are referred to as hot meridians. One of such regions boasts the largest geological formation of Mercury, designated on maps as Caloris Planitia. This name, which is translated as a heated plain, is fully justified, as the temperatures here reach 700 Kelvin or 427 degrees Celsius, making this area the hottest place on the planet. The plain is a gigantic impact crater measuring 1,550 kilometers and accounting for about 2% of Mercury's total area. Estimates show the crater to have formed approximately 3.9 billion years ago, after a collision of the planet with a large asteroid measuring as much as 100 meters in diameter. Mercury was a young and hot protoplanet at the time. The impact would have destroyed a great portion of crust that had barely solidified, and molten lava would have spilled over a vast area of the planet's surface. When it cooled and solidified, the plain was bound by a rocky crust, looking like a bright light spot, easily noticeable against dark valleys surrounding it. The surface of Caloris Planitia is pockmarked with a great number of craters measuring up to 100 kilometers in diameter. However, the most outstanding feature on this plain is Pantheon fossae. Unique in the solar system, this structure is formed by a radial set of 230 troughs, or extension faults, with a width from 1 to 8 kilometers. Most of the troughs do not measure over 175 kilometers in length, with others running much further than that. There is a comparatively large crater, Apollodorus, lying not far from Pantheon fossai's central point, but it is still not clear whether it has anything to do with the troughs. Today there are several hypotheses as to Pantheon fossai's formation. According to one, the giant cracks appeared due to tectonic activity, while another deems the planet's cooling as the reason. Caloris Planitia is an area of flames and light. However, moving slightly to the north, we will find a land of ice and darkness. The tilt of Mercury's proper motion axis is very small, which is why its polar regions are perpetually enveloped in dusk. The sun here either hangs by the very horizon or does not appear in the sky at all. Its rays haven't touched the bottoms of some of the craters for as long as millions of years. There is no wonder that Borealis Planitia, a plain surrounding the planet's north pole, is the coldest region here. The temperature in some of its areas is around 80 Kelvin, which is 193 degrees Celsius below zero. Some deposits of water ice have been detected here in the shade of the mountain ridges around craters. Measuring up to 2 meters in thickness, they are covered by a layer of rocky dust, preventing the ice from evaporation. At the same time, some elevations, which do catch sun rays, may get as hot as 380 Kelvin, or 107 degrees Celsius. Interestingly, such contrasting areas of the surface may lie almost next to each other, but the planet's rarefied atmosphere does not allow them to effectively exchange heat, and so the stark temperature contrast remains. Our tour is getting us to more southern latitudes. Practically on one parallel with Caloris Planitia, but 3,500 kilometers to the west, there is one of the largest craters on Mercury, Rachmaninoff. Its diameter measures up to 290 kilometers, and it's roughly 1 billion years old. There is a tall peak ring in its center. It is formed by tall mountain peaks and measures roughly 130 kilometers in diameter. The rocks in this area are different from the rest of the landscape. They are of a reddish hue, and signs of solidified streams can be distinguished on the surface. This structure is assumed to be of volcanic origin, and is a mark of one of the last volcanic activity events on the planet. Also, the lowest point on Mercury's relief has been registered here, which is minus 5,380 meters relative to the average value for the planet. Beyond the central ring, there are comparatively smooth and dark expanses. Moving on to the south, we will see a gigantic escarpment stretching for 820 kilometers from southwest to northeast. It is called Enterprise Rupees, which in some places towers as high as several thousand meters. There are quite a few escarpments on Mercury, but Enterprise Rupees is the largest. These bizarre features of terrain are believed to have formed as the planet cooled. When Mercury's interior gave away some of its heat, the celestial body slightly shrank, losing roughly 1% in volume. this deformed the planet's lithosphere, which produced gigantic faults. Almost half of Enterprise Rubies is located on the territory of Mercury's largest crater named Rembrandt. Its diameter measures 716 kilometers, and the wide basin contains a great number of smaller features of relief. For example, there are small mountain ridges running from the crater's outer ring to its center. Their width lies within 110 kilometers, and their length may reach 180 kilometers. Another ridge forms a ring roughly 400 and It is believed that more detailed studies of the rocks forming the crater's surface should help us better understand Mercury's inner makeup and the processes running in its interior. In spite of close attention paid to Mercury by astronomers, and in spite of the advancement of observation equipment, the planet is still mysterious and largely understudied. However, even Mercury cannot stay unexplored forever. Even at this moment, the Bepi Colombo spacecraft is on its way, rapidly approaching this celestial body. It is a joint project of the ESA and Japan. The equipment on board the spacecraft will help collect data on the planet's surface and atmosphere composition, study the magnetosphere and solar wind, and update information on the relief features. Bepi Colombo has passed Mercury before, but there are still a few elaborate maneuvers to perform up ahead to break speed and enter operational orbit around the planet. It is estimated that this will have happened by 2025, after which the spacecraft will go on to collect and transmit data. Venus is the Sun's second closest planet, lying 0.72 astronomical units away from the system's center. Its orbital period equals roughly 225 Earth days. Interestingly, every 584 days, the distance between Venus and our planet shrinks to its smallest at approximately 0.25 astronomical units. Notably, Venus faces the Earth with one and the same side throughout their closest approach. There is no hard evidence to account for this fact, but it may be either due to the tidal forces exerted by our planet, or else it could be a mere coincidence. In terms of its physical characteristics, Venus resembles the Earth in many ways. Its average radius equals 6,052 kilometers, or 95% that of the Earth, and its mass is 4.87 times 10 to the power of 24 kilograms, which is 0.82 that of our planet. Every 243 days, Venus completes a full rotation on its axis, and the rotation axis is tilted at 3.4 degrees with respect to the ecliptic plane. For a long time, Venus has concealed its real face from observers on the Earth behind a veil of its dense atmosphere and thick clouds. This gave rise to a whole plethora of highly imaginative hypotheses and assumptions. Some of them claimed that there was a highly advanced civilization concealed under the planet's impervious outer layer, while others suggested that there was a world that was home to peculiar life forms. Until a certain point in the recent past, assumptions about Venus were to be confined to the realms of fancy. Space flights and the advancement of radio location technologies proved to be a major breakthrough that made the desired answers closer than ever. For example, it turned out that radio waves of a certain range pass freely through the planet's atmosphere and get reflected from solid rocks. This effect made it possible to make the first maps of Venus back in 1978 by the orbiter Pioneer Venus 1. Soviet orbiters contributed to the collected data, but the maps were accurate up to 1 to 2 kilometers and outlined only the largest features of the Venusian terrain. This is the reason why it was necessary to go on to send the Magellan orbiter, a large specialized radar. In the period from 1990 to 1994, images of 95% of the planet's surface were beamed back to the Earth by the spacecraft. Interestingly, their resolution reached 120 meters. The information collected by the Magellan spacecraft is still considered the most exhaustive and accurate data about the Venusian surface. Before talking about any planet's surface, it's worth looking at its inner makeup. According to the most reliable and well-grounded theory, Venus has a metallic core at its center, whose mass accounts for as much as 25% of the planet's overall mass. Observations show that Venus has no magnetic field, which is why the metallic core is more likely than not in a solid state. It is embedded in a silicate mantle as deep as 3,000 kilometers. Its upper layer is a solid crust, whose average thickness measures as much as 16 kilometers. It is posited that Venus's lithosphere doesn't form tectonic plates on account of high temperatures and a high viscosity of the rocks. This makes the planet's geologic activity quite different from that on our Earth. Venus is also peculiar for not having that many large impact craters. Large areas of its surface are covered by basalt plains that formed from solidified lava. Some features of the relief found here are uniquely Venusian and are not to be found on any other planet in the solar system. An example of these is tesserae, highly ragged mountainous areas resembling roof tiles. Arachnoids and coronae are two other unique types of the planet's terrain. Round, roval structures with diameters measuring several hundred kilometers. They appear to be impact craters, but their origin is different. Rather than celestial objects in fall, they formed as a result of tectonic processes. An unprepared viewer will not easily notice any features of the Venusian terrain, even in processed images. That's why let's take a look at the elevation map of the planet's surface, where areas of different height are marked by contrast colors. The region that instantly catches our eye is the largest elevated feature on Venus, nicknamed Aphrodite Terra. Areas like that may well be considered conditional continents of the planet. Aphrodite Terra is a gigantic territory stretching along the planet's equator. Its mountainous relief is rather elaborate. According to different estimates, the length of Aphrodite Terra may reach 18,000 kilometers and the width around 5,000 kilometers. Depending on the method of defining the continent's borders, its area is estimated in the range from 29 to 41 million square kilometers.
When it's crunch time, we've got your back. And your dinner. Panera.
Which is comparable with the area of Asia. If we look at Aphrodite Terra, we will see three vast areas: Atla Regio, Thetis Regio, and Dovda Regio. The first one of these is located in the eastern part of the continent and is notable for the highest volcano on Venus, Mount Mons. The distance from its foot to its peak measures around 5 kilometers, and the overall height above the average level of the celestial object's surface is anything from 8.3 to 8.8 kilometers, according to different estimates. The volcano is currently dormant, although there is evidence that it erupted comparatively recently in geological terms. Namely, it can be inferred both from solidified lava flows and lack of impact craters on the volcano's slopes. Dovda Regio sprawls in the western part of Aphrodite Terra. This is a region particularly attractive in terms of tectonic processes. The mountain ridges here run in different directions, which means that there are several forces tearing at the crust simultaneously and deforming it. Moreover, deep crevices have been discovered here that contain traces of lava spillage. These may well be considered the most bizarre volcanoes on the planet. We're moving on to the west, to the very edge of the continent, where the alleged descent points of 4 Venera probes can be found, and 2 of the probes were destroyed by the planet's atmosphere before reaching the surface. All these are located in the southern part of a vast lowland region known as Guinevere Planitia. It stretches for many thousands of kilometers and is quite a match to Aphrodite Terra in terms of area. Even though it is called a planitia, the area has an elaborate relief, which is a mixture of various geologic formations. It is thought that the planet's crust was being crumpled by tectonic forces for many hundreds of millions of years, and this produced the ridges and the folds. At the same time, the lava spilling from the crevices spread across and solidified, filling the lowlands with smooth basalt plains. As a result, this region is rich in both flat areas and clearly defined uplands. The western part of Guinevere Planitia borders on the so-called Beta Regio. As this vast area looks quite bright in photos, it is one of the first features of Venusian relief that got its own name. Beta Regio is an elevated area which is more or less round-shaped with a diameter measuring roughly 2,500 kilometers. Its eastern part is the final abode of the debris of the spacecraft Venera 9 and Venera 10, the spacecraft which beamed back to us the first ever photos of Venus back in 1975. They also gauged the atmosphere's parameters and sampled the soil, which turned out to be similar to basalts back on the Earth. All this information allows us to assume that Beta Regio is the largest volcanic massif on Venus. That is why this area offers highest chances to discover active volcanoes on the planet. We're moving on to the north now, to the second largest conditional Venusian continent dubbed Ishtar Terra. It stretches for roughly 8,000 kilometers east to west and approximately 2,500 kilometers north to south. The territory's area equals about 8.5 million square kilometers, which makes Ishtar Terra only slightly larger than Australia. In the center is the largest volcanic massif on Venus, Maxwell Montes. They tower 11 kilometers high above the planet's average level and 7 kilometers above the rest of the relief around. The highest peak in the center of the region is a comparatively flat plateau, measuring roughly 200 by 400 kilometers. The difference in height doesn't exceed 1.5 kilometers, so it is extremely difficult to distinguish separate peaks, as the measurements are not accurate enough. Maxwell Montes are the coldest region on the planet. The temperature here is as low as around 380 degrees Celsius, and the atmosphere is about twice as rarefied as near the surface. Still, it is 44 times denser than that of the Earth. Another thing about this region is that it looks quite bright in photos, which means that the surface of the peaks and slopes is likely to be covered with some substance which reflects radio waves remarkably well. It is thought that it could be metallic compounds with impurities of sulfur like pyrite, hematite, or galena. Exposed to high temperatures, these substances can vaporize from the surfaces of lowlands and then precipitate in colder mountainous regions as fine grain reminiscent of snow. While examining the Venusian surface, you can't help thinking this: are all these amazing and mysterious places to remain unexplored by humans? Is there a chance of us ever leaving our footprints on this planet's surface? So close, yet so forbidding. Because the atmospheric pressure on Venus is about 93 times that of the Earth, and the temperature near the planet's surface is on average 737 Kelvin or 464 degrees Celsius. These conditions are so extreme that even space probes specially designed to explore Venus last no more than an hour. As for terraforming Venus, this idea seems totally unrealistic. On the other hand, there are in Venus's atmosphere some layers whose temperature and pressure are close to those of the Earth. In the last century, ideas were even put forward about designing a habitable base, hovering in the planet's atmosphere suspended from special aerostats. Still, in reality, the actual possibility of putting such projects into practice remains an open question. And either way, Venus is awaiting her heroes, and her secrets will sooner or later be revealed. Approximately 252 million years ago, the Earth's biosphere suffered from a tremendous blow. Almost 96% of marine fauna, around 70% of land vertebrates, and roughly 83% of insects perished within a period really short by geological standards. The causes of this disaster are still obscure, but whatever it was, the dreadful calamity didn't wipe life off the face of the Earth. Quite on the contrary, it proved to be a milestone, marked the beginning of a new era. This is when there emerged the most well-known prehistoric creatures, dinosaurs. The Permian-Triassic extinction event marked the beginning of the Mesozoic, a new era in the geologic history of the Earth. It began approximately 252 million years ago and continued for around 186 million years. This was a time when our planet was actively transforming and gradually assuming its today's looks. The most crucial tectonic process of the epoch was the splitting of the single supercontinent Pangaea. First, it broke down into two landmasses, Laurasia and Gondwana, which in their turn went on to form the continents we know today. With several large, mutually independent territories separated by seas and straits, the conditions were perfect for independent ecosystems to emerge, which gave impetus to new evolutionary adaptations. In terms of climate, the Mesozoic was the warmest era in the entire history of multicellular life forms. Throughout this era, there was no ice shield even at the poles that would cover the ground for a long term. Still, temperature would drop from time to time, which forced both flora and fauna to adapt to the newly imposed conditions. The Mesozoic comprises 3 periods, and the first one is known as the Triassic. It began around 252 million years ago and continued for around 51 million years. This was the time when tectonic processes in the Earth's interior were just starting to break Pangaea into separate continents, and the supercontinent remained home for most of the period. The Ural Ridge, one of the oldest mountain ridges existing to this day, completed its formation in the Triassic. At the time, the mountains were in their salad days and comparatively high. The period's climate was relatively dry and hot, which is why there were lots of deserts at the time and the area of inland bodies of water diminished. There was 10 to 15% of oxygen in the air for most of the Triassic, and then, around 215 million years ago, its level gave a sudden leap to reach as much as 19%. The reasons for this phenomenon haven't been established for certain, but it is assumed that it may have had something to do with the evolution and spreading of certain varieties of marine or land plants. Prehistoric seed ferns accounted for the overwhelming majority of the flora of the day, but later on they were gradually ousted by more progressive groups of plants. Those included cycas, ginkgo, and prehistoric conifers. Many of these orders have survived to our day, although now they are not as diverse as they used to be. Marine life, meanwhile, was following its own course of evolution. The oceans, emptied by the Perm-Triassic extinction, were gradually populated by turtles and teleosts, and the first ichthyosaurus held the niche of large predators. Later on, they were to become reptiles best adapted to aquatic environment. But in the Triassic, these creatures were still rather primitive. An example of these is Symbospondylus, which lived 240 to 210 million years ago. This giant sea saurian measured 6 to 10 meters in length and ate mostly fish. This impressive creature had a long, thin body, half of which was a flexible tail. Its head was rather large, and the elongated, sharp muzzle boasted a nice set of small and sharp teeth. Symbospondylus' limbs looked like diving fins, but it appears they were used only to stabilize body position in water. The saurian's skeleton structure suggests that it traveled through water by making wave-like movements, and generally speaking, was rather clumsy.
Okay.
The most common representatives of land fauna of that time were Archosauria, prehistoric ancestors of dinosaurs, crocodilomorpha, and birds, as well as other animal species. By the middle of the period, first dinosaurs evolved from ancient Archosauria as independent species, but there was still a long and hard struggle for survival up ahead for them. It was only by the end of the Triassic that dinosaurs started to establish their dominance in the Earth's biosphere after sharply growing in size, which incidentally coincided with an increase of oxygen in the atmosphere. With dozens of films and thousands of books about horrifying saurians, anyone today would be familiar with what they looked like. At the same time, these giants seem to eclipse other species, which are by no means less important and interesting. For example, Oligokyphus, a small creature that lived in the late Triassic around 200 million years ago. This small and deft little animal was a genus of cynodonts, prehistoric animals that differed from mammals in some not very clearly noticeable traits. Oligokyphus had a thin, flexible body measuring around 50 centimeters. It grew fur and generally looked like a weasel. Warm-blooded and herbivorous, it was widespread on the territories of today's North America, Europe, and China. Even though it isn't known whether Oligokyphus had a pouch on its stomach, the structure of its skeleton allows us to assume that its babies were quite small, which is typical of today's marsupials. It is also highly likely that Oligokyphus fed its babies on milk. Another assumption about these creatures is that they dug burrows and made homes there. They also took great care about their babies, which may be evidence of a comparatively high intellect. Unfortunately, these creatures perished at the beginning of the Jurassic period, supposedly due to lack of food and heightened competition. Still, they remain the oldest prehistoric animals that look like today's mammals most. The Triassic-Jurassic mass extinction heralded the end of the Triassic period. A great number of amphibians, some Archosauria, other reptiles, as well as many plant orders, vanished from the face of the Earth. Among the possible reasons for this disaster are volcanic activity, a change in the global ocean level, and sudden climate change. Either way, the extinction event vacated a number of ecological niches, which allowed dinosaurs to establish a firmer position on the evolutionary arena of the Earth. The next period of the Mesozoic was the Jurassic. It began about 201 million years ago and ended about 145 million years ago, which makes it roughly 56 million years long. This was a time of large-scale tectonic movements and reformations. It is in the Jurassic that the supercontinent Pangaea finally split to form several landmasses mutually separated by shallow seas. If we look at the map of the Earth at the end of the Jurassic period, we'll be able to distinguish the shapes of some of today's continents, although they would be positioned in unexpected places. Since the new continents were mutually independent, there emerged isolated biosystems. That is why some animals and plants that were abundant on one continent would be non-existent on another. The Earth's climate was warm and humid for most of the Jurassic period, and by its end, a comparatively short cooling occurred. Great areas on land were covered with tropical forests, which were for the most part cycas, gymnosperms that resembled palm trees. Conifers were also widespread. Their looks were reminiscent of today's cypress trees and pine trees. On land, meanwhile, there started the epoch when dinosaurs positively flourished. Their diversity was rich, and they held most ecological niches while dominating almost every single one of them. Among these creatures, one could come across both small saurians the size of a cat and real giants. Herbivorous dinosaurs known as sauropoda came to be widespread in the Jurassic, with some typical representatives like Brachiosaurus, Brontosaurus, Diplodocus, and others. They resembled each other very much. The largest one, Titanosaurus, measured as much as 25 to 30 meters in length and could weigh over 75 tons. An unusual feature typical of sauropoda is the so-called sacral brain, a widening in the hind part of the vertebrae that hypothetically could contain 20 times more nervous tissue than cranial brain. Today it is posited that the sacral cavity was likely to be filled with a glycogen body, which was a source of additional nutrition for the giant saurian's nervous system. Alongside dinosaurs, other animal species were evolving as well, such as mammals, reptiles, and arthropods. The oceans were richly populated with bivalve mollusks, which in many ways resembled their today's descendants. The apex predators in the marine food chain were various saurians like Ichthyosaurus and Pliosaurus. Looking at Ophthalmosaurus, which lived at the beginning and the end of the Jurassic period, and comparing it with Symbospondylus, which lived earlier, it may be hard to believe that these animals are in fact related. Ancestor Symbospondylus lived 240 to 210 million years ago. Length 6 to 10 meters. Elongated body and head. Badly adapted to aquatic environment. Descent